Last slide. This is not homo. This is not a homo. Another homo is this one. So, right? This was the homo, right? Yeah. Okay. But we do not have enough time to solve this problem. I believe that using the answer key, you can understand and how to map from ER diagram to relational schema diagram. The key part is how to handle this quick additive relationship. Okay, so let's continue. Don't worry. we have announcement. So very hard to read. It's not yet. Not this one. Okay, this one. This is the summary of the last class. So we are discussing about the relational operation and relational algebra operation and relational algebra expression. Just like the mathematics that you learn in your K-12. Okay, so you first learn the operation, what is a plus, what is a minus. Then you will eventually learn the equation. Using that equation, you can solve the problem. Same thing. After we design the relational database schema, that is based on the set theory. So set means in relational model is a relation. So using that relation, we model the database. So we can put the data into such a database, then we can access the data. How? At that time, we need operation to handle, to manipulate, to access such a data. For that operation, we learn select, project, join, equijoin, natural join, union, intersection, difference, Cartesian product, and division. Also, by combining or combination of such a sequence of relational operation will be relational algebra expression. Like the equation x squared plus y squared plus z squared equals something like that. You can use many operations to represent the mathematical problem using equation. Same thing. Using relational expression, algebra expression, you can convert realistic theory that you define in your page 1. In page 2, we can convert such a realistic theory to relational algebra expression using such an operation. These are the fundamental basic operation. In addition to that, we are going to learn the additional relational operation, which is aggregate function and grouping. When I learned the relational database, which was Oracle first time, it was used for actually data analysis, not the databases, the data engineer or the software engineer programmer. No, first time data analysis. They learn. Even I worked for the bank at the time. IT department, no, they did not know how to use the SQL. Instead, the headquarters, department, the data for data analysis, they learned how to use the SQL. They tried to use the SQL to make a report, daily report, monthly report. So directly use the SQL at that time. So one of the reasons why they use such a SQL directly, SQL provide very, very powerful function for grouping and aggregate function. What is the statistical function that you know? Statistical function. Think about your Excel sheet. When you are using the Excel, you probably use the sum, right? A lot of time. This icon. Click the icon, that's sum. What else? Average. Standard deviation. And maximum. Minimum. Median is a little bit different. Okay? Median is a different concept, but so this function provides very nice, so very powerful operation to represent, to characterize the data. We have a bunch of data sets like the grading report. I have a whole grade. I do not know whether this group, this semester is better than other. How can I judge your performance? If I have average, so the average is 70, but it's better than 65 last semester, then it's better. So we can use such a statistical function to analyze the data. That's called a statistical function. Not always 70 is better than 65, sometimes. For example, all 20, 30, 20, and 190, huge gap. Instead, this one is a 60, 65, 70, 61. Even though average is less, it has less standard deviation. Then this year, we cannot say this is a good class. Okay, huge difference. So instead, this one is better. So using such a statistical function, we can analyze the data. It's a very, very powerful tool. In the program language, sometimes it's a built-in function, sometimes you need to use the call such a function. But in SQL, it's a even built-in operation. So that is called the aggregate function and grouping. Why this is important? Because, for example, I like to check average salary of each department. So without using such a relational database, how can you do such a thing? Average salary for each department. You need to know first salary information. Also, you need to know employee for each department. You need to group. Okay, how can you group it? How can you do the grouping? You need to sort the data actually. Sort by department name, department number. This is very, very expensive operation. It's not easy. You need to implement something the array and sort the data and finally compute in your program language. But SQL provides the built-in operation. Grouping, then collect the salary, then average. Then you can do this kind of operation, just one operation. That is aggregate function. So such a statistical function requires a grouping. Group by operation. So group by department, group by the gender, group by city, group by something. Okay, and you can apply the statistical function, that is the sum, average, maximum, minimum, count, not median. Okay? So, for example, how can we use? Symbol is F. Okay? F, then grouping factor. This is called grouping factor. Will be left-hand side of F and right-hand side there is an operation. Operation means the statistical function. Function, not operation. So function. So for example, the annual count means for each department, I'd like to count number of employees. So input is the employee, then I'd like to count the number of employees for each department and average salary of each department. So grouping factor is the left-hand side and right-hand side is the function, statistical function. Does it require only the one attribute for the group? No, it doesn't have to be. It can be the annual plus the annual, then the name. you can do multiple attribute for grouping factor. And also, you can compute not only the one statistical function, multiple statistical function. It's a very powerful tool. Okay? However, anyway, when DBMS process the list aggregate function, they require what? Sorting operation. So probably they will use a very fast sorting algorithm, binary sorting, something sorting. Anyway, it requires sorting, so you should be careful whenever you use this one. Sometimes I have seen the source code, database programming source code that put all of the database theory has group Y and statistical function. Okay? Even though when they retrieve the name of customer, at that time group by customer, that statistical function is a waste of resources. So very, very slow. So you should be careful when you are using this one. What about this? In this case, what is the difference between this one and this one? It's exactly the same, but it has rename operation, row rename operation. Otherwise, it will be just DNO count and average. So instead of that, you can specify the name. Also, here DN, even though DNO is not selected, DNO should be retrieved. Otherwise, you don't know which average is this, which number of employee is this. So grouping factor should be retrieved automatically. Okay? Sometimes you do not have the grouping factor. Left hand side is empty. What does it mean? We consider input as one group. In this case, count, SSM, average, salary, which means total number of employees. The average of all employees. We consider input as one group in this case. Okay. How many data will be returned? Only one tuple will be returned. Output is always the relation. Okay. So this is the aggregate function and grouping. So we will see again during the SQL. So this is the example of the other example of the F, the aggregate function. So we have max, minimum, sum, and by DNO count. Okay. The next operation is the recursive closure. We have the recursive set relationship, like the supervisor, supervise, employee, supervisor, any supervising, right? So at that time, it's easy to make the query in English. So retrieve all supervisor of a specific employee, or retrieve the all employee supervised by me and the supervisor of my supervisor, something like that. It's a recursive code, but it's not easy to implement. So in latest SQL standard, we will learn what is the standard of the SQL. Latest SQL standard supports such a recursive query. But all SQL sum of the relational DBMS, which is based on the old standard, they do not support such a recursive code. So how to address such a problem? We need to select first. This is the example of the retrieve the supervisor of James group at all level, which means I supervise him and I try to retrieve not only him and his supervisor also. And if there exists, the supervisor of the supervisor and all level. But this is not supported in all the standard, but the latest standard supports such a recursive. Without using such a things, we need to retrieve first. So 8886655 is the gross social security number. Okay. Then we have 3334455 and the 987, something like that, 2 employee. So for 2 employee, so supervisor of this one. Then finally the union, this and this, then get the data in case of recursive. The last means last of my slide, and this class there are little bit more operation, but they are straightforward, you can understand. And also each DBMS provide their own operation sometimes, which is not in standard. I'm not going to cover such a specific operation using specific DBMS. So we have learned about join operation. Can you remember what is a join operation? Join is combination of 2 operations. First, 2 relations. How do you combine 2 relations? Cartesian product. Cartesian product plus condition, selection operation. So join is actually the Cartesian product and selection condition. So this is the join operation, which means when you combine 2 relations, so we have bunch of list of tuples that combine A and B, then will return that satisfy with the join condition. In other words, if the tuple does not satisfy with the join condition, it will not be returned. Okay? That's a very strong condition. For example, I'd like to join employee and department whose social security number is equal to manager social security number. We have learned about this example. Then we first combine employee and department and check the social security number and manager social security number. It will return only Franklin, Wang, and the Jennifer Wallace and the James Burke. 3 match 1. Okay, the others are not actually supervisor. Okay, 3 data will be returned. That's what I learned from the join operation. However, your boss asks you, I need all information about employee, like this. Then check if an employee is a manager, put the department name. Otherwise, just null data. How can you do that? Actually, you can do that using union operation. You can combine. First join, okay? Then the other. Join for this one, and this one. For the others, you can use the minus. You can use the minus operation, then combine using union operation. Instead, we are going to define outer join. Outer join means the traditional join operation allow only match data, like this. In outer join, we will keep all the data. Okay? Left outer join. Left outer join means we keep all the data from left hand side, which means John, Franklin, Elisa, Jennifer, Ramesh, Joyce, Ahmed, and James. Whether or not they are the manager or not, it doesn't matter. Keep all the data left hand side. If they are matched, which means they satisfy the join condition, put the department name. Otherwise, there's no managing department, right? So no data. So we keep all the data left hand side and right hand side only match the data. That's called the left outer join. Somebody may be curious, what about the right outer join? Yes, that's possible. We keep all the data right hand side, which means, I will give the example. We have two relations, R and S. So column 1, column 2, column 3, we have D1, D2, D3. This one is 1, 2, 3, A, B, C. Okay. Then 2, 3, 4. A, B, C. So who will join? R1 and R and S with a join condition C1 equals D1. Okay? Then what will be written? How many tuples will be written? First, Cartesian product, which means match all of them who will have 9 of the tuples. Among them, match one. One? No. 2 match it. So which means C1, C2, D1, D2, 2B, 2A. Right? Also 3, yes, it's a match it. 3C, 3B. This will be returned. This is the join operation. If we perform the left outer join, we use the symbol to represent the left outer join like this one. Keep the whole left hand side. First, we will keep all left hand side. Okay? 1, 2, 3, A, B, C. C1, C2, D1, D2. Then check whether match. What? No matching. So which means null, null. Okay? 2, yes, it's matched. 2A. 3, matched. 3B. This is the left outer join. What about right outer join? As you can expect, right outer join is this side. Open right hand side. So C1, D1. C1, C2, D1, D2. First, we keep all right hand side. 2, 3, 4, A, B, C. Which means this is 2, yes, we have matched one, 2B. And 3, matched one, 3C. No data for 4. So this is the output, right? Outer join. What about the both outer join? Left and right. Yes, it's possible. That is called full outer join. Full outer join means R join and both sides. C1, D1, S. We keep C1, C2, D1, D2. Keep all the data, both left and right. First left, 1, 2, 3, A, B, C. Then null, null. This is 2A, 3B. And also keep 4, C. Then null, null. This is a full outer join. Okay, so left outer join, right outer join, full outer join. This is frequently used for reporting. Think about, I need a report for employee, whether employee is the manager or not. In case not manager, just null data. In case manager, you can put the department name. Okay, that is a full outer join, left outer join, right outer join. outer join operation. And any question? We will practice left outer join, right outer join, full outer join, and during the exercise, especially left and right outer join. Actually, left outer join is enough. Full outer join is not frequently used. It's complex. Okay, but left outer join. In case of right outer join, you can just change the order. So left outer join is frequently used. If you believe left hand side is important, you want to see everything, okay? Then you can keep left hand side. So quickly we will see the example of the relational algebra and their expression. First query is like your examples in your page 1. Retrieve the name and address of all employees who work for the research department. Can you get the name and address of employee? Which relation? Where can you get such an information? Name and address. Project? Name and address of all employees. Employee relation. So we need to access employee relation. However, there is a condition. Who works for the research department? Where can you get the RESERCH, research department? Unfortunately, not in employee. If this is the department number 1, something like the DNO is equal to 1, then it's simple. You can access the employee, use just the select operation. However, this is a research department. So, first we need to access research department. Then get the department NO, department number. So, first access department and what we need. D name is equal to research. Research. And say rename relation research. Okay? Then using that information we can access the employee data. How? We can join two tables R underbar research join with the employee. Which one? D and O in employee should same as D number in R underbar research, which is retrieved from the previous relation. This is the research employee. Finally, we can access name and address of name, first name, last name, address of research employee relation, then this is the result. Okay? This is the operation, relational algebra operation by operation, step by step. We can combine into one relational expression. How? Department we can just plug it. Research department, simplify, and DNO or D number, and deploy, then name, address, result. This is one. Also, you can change. You can take out this select operation outside, which means You can join department and P number, E and P. Then apply P name equals to research. Apply. Then apply projection. This is another. Okay. This is how to make the relational operation, relational algebra operation, and relational algebra expression. Next, retrieve the names of employees who have no dependent. What does that mean? First, you need to understand your query, right? If you do not understand the what the query asks, you cannot make the relational algebra expression. That means you cannot make the SQL later. That's correct. So retrieve the name of employee. That's okay. We can access the employee relation to access the names. However, who have no dependent? That means single, right? Or the without child. So you understand. Which means we need to check the first employee. So here it is employee information. Then check dependent. Exists? No, not exist in the employee. Which means there are several different ways. This is one way. Employee, we can get the old employee social security number. Okay? Also, we can get the employee social security number from the dependent. What does that mean? Employee who has dependent. Then we can minus. This is employee. This is the employee with dependent. We need this. We can take out minus. So minus. Then this is the social security number only. Right? This is only the social security number. So we can use at the time join operation, especially natural join. Right? Natural join will automatically join same name of attribute. This SSN is here, employee also. So we can get the name and first name and last name of the employee who have no dependent. This is the power of the SQL. Actually, SQL can make your program simple and very, very simple. Okay? You don't have to get the whole data. So I have seen the database programming and the project like this. Their queries are very, very simple. Only one type. Select column name from one table. And with only where condition, sometimes without where condition. Retrieve all the data into your program. They believe they know everything about the programming. Okay, then assign the variable memory structure, then put all the data memory and manipulate here. For example, join, yes. This kind of thing, minus the without dependent, they process all the thing over here. Problem, first problem, network transfer. When you are testing your local database, it's okay because it's in the same data, but that's only for testing. In real life system, this database located in remote. So it's a network bandwidth. Second thing, memory. Because anyway, you need to put such a retrieve the data on your either memory or file system. File system very slow, right? You need the I/O. Think about the 1 billion of data. So you probably use the memory, which means variable in your program. It's a waste of your memory. Then third, computation. You need to implement all logic in your program. So computation, your programming will be very, very complicated. I have seen a lot, okay? So please don't, I understand, in your programming class, this is not major part. So you probably focus on the programming. Somebody only did copy the program that you have used in your programming class. I have used a database, so I believe this is good, but that's for programming part, this part. So it's okay in the programming class, not database. Okay, database, you can do the same thing, but it's a waste of resource, waste of the bandwidth, a lot of it. So please implement as many database objects as possible in your project. I don't care actually how you implement it here, programming part. This is not a competition for programming skill. So I will take a look at how you design, implement the server-side back-end part in your database system. Okay. So this is the relational algebra expression. Then how we can use such a relational algebra expression. Eventually we will learn in the second part of the semester, we will learn query processing. What is a query processor? Have you ever heard about query processor? No? It's like what? Just give me your answer. So we will submit such a query to the DBMS, for example, Oracle, DB2, such an entity. Then DB2 informs Oracle, they should understand what query is. The query processor processes your query. And the more important thing is how to access the data. Do you think how many ways to go to Manhattan from Bridgeport? How many? You don't know? You've never been there? No? Where do you live? Where do you live? Apartment? Or the dormitory? Dormitory, which dormitory? North Shore. How many different ways to go North Shore from here? There are many ways, right? I can take the bus, go to the terminal, then take the taxi. Yes, that's one way, right? You don't want to such a way, right? You want shortest path. It's the same thing in database. There are many different ways to access the data. Even though you access only one data employee, sometimes you can use index. Sometimes you can use the secondary index. Sometimes you don't use anything. You can just use the primary key and binary search. Also, sometimes you can just put a bunch of different things. Query processor will decide fastest way. At that time, how can query processor determine this is a fast, this is a slow? First step of the query processor is decompose a query like by relational operation. Because relational operation is a minimum unit of operation. Separate like this way. This is the query for what? For every project located in Stafford, we treat the project number, blah, 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 blah. How many different tables? We join 3 tables. Oh, one more thing. I forgot one more important thing. I will explain it. So, table. First, we can access the employee first, then department, then project. First, we can access the department first, then project, employee. There are different bunch of different ways. First, query processor decompose the query by operation. Then check case by case. What is the cost of each operation, each way? Cost means what is the cost of your returning home? Time. Okay. What is the most expensive operation in computer? Do you think? To decide the time. What? Which one is the slowest operation? I/O to secondary storage, hard disk drive. So they consider the number of I/O to access the data. Okay, we will learn details during the query processing. So anyway, this relational algebra is very useful for query processing. In other words, when you make the query SQL, if you know such a relational operation, okay, then you can make the fastest query. faster query. It's called the SQL tuning. Output are exactly the same. So in the project, I use the database, so it works very well with the sample data. So I decide to sell my product to the company. Company learn your system, it's okay, but later, weeks later, when they have the many customer, many transactions, your query will run forever. Slow, slow, slow. At that time, you need to think about why it's slow. Query optimizer will determine not always it's perfect, so you need to understand how it works by relational algebra operation. Okay. That is the relational algebra operation. One more thing I forgot to explain. In this case, it's the access retrieve the project number, controlling department number, and department manager, so on. So we need to access project, department, employee. Okay? 3 tables, 3 relations. Do you think how many join conditions we need? 2, 3. So in case we have 2 relations, like this one, how many join conditions? 1. If we have another join over here, like the project, join condition 2, 3, 2, 4, 3. Always 1 less than number of relation. That's very important. In case you have 3 or 4 tables, it's okay. You can easily recognize. Sometimes your query has 10 tables, 20 tables. How many join conditions? N minus 1. 1 less than your total number of tables. What happened if you forgot, missed 1 or 2 of them? What happened? A lot of time, what?
Because join operation consumes a lot of resources.
But you cannot join if you miss the join condition. Instead, it will be Cartesian. All the cases. So sometimes I make a very fancy, nice, the very long, 2-page long query. But it takes several days to be completed. Yes, that's true. But my boss, my manager, come in, just add 1 simple condition, then it will take just a couple of seconds. That's really happen. The Cartesian product will create all combination. Okay, that's huge difference. So don't forget. So in case you use n number of tables, n number of relation in your query, you should have n minus 1 join condition. So in this case, we have 1, 2 join condition. Then relational calculus. What is the main difference between the algebra and calculus? Algebra provide operation, basic operation, and calculus, based on that operation, you can solve the higher level problem. In this, the relational algebra, relational calculus, higher level problem means it's a sequel. So we can solve such a problem as a sequel like this way. Have you ever seen this kind of notation? T bar condition T. Yes, I think so. In your math class. So which one is the same as this note set? Number 1, x bar x is bigger than 0. X is integer. Just like that, right? It's a different notation. With the condition, this is it's a set of elements. Case, all the case. So, same thing. If we use such a notation, this condition is directly show the output of the data. Okay? For example, to find the first and last all employees whose salary is above 50,000, we can write the code. Using calculus, This is just a condition. Employee and salary is bigger than 50,000. That's different from algebra. So usually most of case, relational algebra show how to access the data. Okay? Even step by step. While relational calculus show the condition, output of the data. It focuses on the output. So query processor would like to use relational algebra to process a query. On the other hand, calculus can be used for final output that will be used for where condition in SQL later. Okay? So that's it. Pretty much that's the almost end of the relational algebra, except one thing. So we learn what is this? Selection. And what else? And aggregate function. Okay, grouping. What is the basic syntax of a SQL? Anyone who ever used the SQL? Select. This is very well-known statement. Select from where? Right? Select has what? Attribute, column. From has it's a table name. Where has condition. This here. This here. Join condition over here. And each relation, all relation go to here. And if you have the group by, this goes to here, and function goes to here. Actually, relational algebra is the basic of SQL. Almost the same, not exactly same, but 95% I can say the same. Because when Dr. E.F. proposed the relational database model, he proposed only this part, not implementation. Later, somebody believed this is a good idea to manage the data, very large the data, so adapt then. We need to language it, programming language to access data. Anyway, relational database is on computer, not human being. So we should have the language to try to implement database language, okay, based on relational algebra and relational calculus. This is called structure query language. SQL. It's called the SQL. Sometimes the SQL. When I learned the first time the database and database language was called SQL instead of SQL. But when I moved here, I realized United States most of guys call SQL instead of SQL. Doesn't matter. Okay? So SQL word. But nowadays I confident to call it as a SQL. As you know, Q is not actually pronounced in my mother tongue. It's very hard to pronounce Q correctly. Whether or not you read. It's the same problem when you learn the foreign language. Some of the pronunciation is very, very difficult. Another example is the S and Z. We do not have such a pronunciation. Very, very tough. The SQL, when I say SQL, it's easy, but SQLQ, I don't think that's correct pronunciation. It's my accent. Anyway, so I think that this was the homework. No? No? Then it will be your homework by next week.
Which one?
So exercise, end of the chapter. This is just like the page 1 and page 2. Page 1 you define such a thing. So I try to give you the list of the query. In English, it's a 6 query. Why don't you make relational algebra expression. It doesn't matter, you can use the step-by-step by operation. At the time, don't forget rename. Otherwise, you can make it very long. Is there any common answer or general answer? No. Sometimes many different answers are possible. So don't be frustrated if you get the deduction from the grading. You can just ask me after you got the result.
In the same day, like for tomorrow, like phase 2 and this homework together?
Tomorrow is separated. It can be same time, whatever, okay? Too much? Then I cancel the extension of this one. So please, so this is a good practice. So usually homework don't be stressful, okay? This is a 4-year practice, okay? Do not waste your time by copy and paste or just read. The total percentage of the homework is less than 10% in your final. Usually I try to give you the minimum. As long as you submit on time, you will get the certain portion, which means later in the final, the difference is